Welcome to our third video in the series of air and water reactive materials. In this video, we will focus specifically on the metallic hydrides, substances that actually have hydrogen as an anion, negatively charged, and the metallic carbides, one of the rare circumstances where carbon actually exhibits ionic bonding in its carbide state. Now, we'll start with the ionic hydrides, the metallic hydrides. These are powerful reducing agents. They're really good at losing electrons and forcing the reduction of other substances. And we can break them into simple categories. There are your simple metallic hydrides. These are where you have metal ions that are bonded to hydrides with a negative hydrogens with negative charges. There are the metallic borohydrides, which are a little bit more complex. And then there are the complex aluminum hydrides, which are probably the most unique of the three. Now for the simple ionic compounds, these are your binary compounds where we have a metallic ion that is bonded to a hydride ion. So literally we're talking about, for the most part, any kind of aluminum, lithium, sodium, calcium, magnesium. We're looking for literally one other element, one other metal attached to the hydride. And what's interesting about these hydrides is that they are capable of reacting with water to form hydrogen gas. And the hydrogen gas, as you know, is quite flammable and quite potentially explosive depending upon how much is created. And so as a result of this, we find that these hydrides are stored in sealed containers that can keep out moisture so as to prevent this kind of reaction from happening. Now, there's a number of ways that they can do it. Sealing's one way, but also covering them with things like petroleum oil or kerosene or something along those lines. And when it comes to extinguishing the fires, dry powder has to be used because of that reactivity with water. For metallic carbides, carbides are compounds that have metal ions and carbon ions. And the most common examples of these are aluminum carbide and calcium carbide. Now, aluminum carbide is prepared pretty simply. If you take aluminum oxide, Al2O3, and heat it in an electric furnace, so again, a dry heat, with coke, carbon, what can happen is that the aluminum carbide will start to form as the carbon replaces the oxygen in the aluminum oxide. Now, what's interesting about these aluminum carbides is they are water reactive, and as a water reactive compound, what they'll produce when they interact with the water is they'll produce methane. And methane, as you know, natural gas, is quite flammable. Now, the other big group here are the calcium carbides. Now, calcium carbide is produced in a really similar kind of process. If you mix coke and lime, so you've got calcium carbide you've got your carbon from the coke and your lime, and you heat it at a high enough temperature in that electric furnace, the calcium carbide will be produced as a result. Now, unlike aluminum carbide, which reacts and makes methane when it is reacting with water, the byproduct of calcium carbide and water is acetylene. And so there's actually a really cool reaction that you can do. I wouldn't recommend doing this with pure water, but if you take calcium carbide and just put a little bit of ice in it, it'll immediately start to fizz up. And the fizzing that is going to form out of that is actually the acetylene, which you can light with a match or a burner or something like that, and produce just these little pockets of flame. And the reason you recommend the ice with that is it slows the reaction down considerably. So that's all for this particular video. Again, short video here talking about the carbides and the hydrides, two unique but kind of rare classes of materials. Until next time, have a good day.